Here's problem number 5, sample test 2. Assume that the 3 blocks shown in the figure move on a frictionless surface. 45 Newton force acts as shown on the 3 kilogram block. Determine the acceleration of this system. First thing we'd like to do is blob these 3 together, treat them as one mass of total mass 6 kilograms. As we complete this free body diagram, we would have weight and we would have a normal force, but they will be transverse to the motion. So we'll end up with just this 45 Newton force supplying our acceleration for this system. As we set up Newton's law for this, we'd say the summation of all the forces in the x direction is equal to our total mass for this blob times A, and that's equal to F. So the acceleration will equal F divided by this total mass, all the other forces being internal, and that's going to be 45 newtons divided by 6 kilograms, 7.5 meters per second squared. Okay, nice. That's our acceleration. Alright, part B. What's the tension in the cord connecting the 3 kilogram and 1 kilogram blocks? Alright, we have to go internal to the system to do this, and probably one way to do it is to focus on the 3 kilogram block. Do a free body diagram of it. We've got our force F of 45 newtons going to the right. We're going to have a tension force going to the left. Of course, we're going to have weight equal to m3g, and then we'll have a normal force N3 going up. As a result of all these forces, it manages to accelerate to the right at 7.5 meters per second squared. There's our free body diagram. As we set up our equation for that, we would say that the summation of all the forces in the x direction is equal to m3a, and that is equal to F minus the tension. So in other words, the tension will equal F minus m3a. And that will be equal to 45 newtons minus 3 times 7.5, or 22.5 newtons. So that's the tension in the cord. What's the force exerted on the 2 kilogram block by the 1 kilogram block? Well, let's do a free body diagram of the 2 kilogram block. Labeling all the external forces acting on it. We've got the pushing force from block number 1 on it, and nothing else in the x direction. Of course, we have weight, m2g, and we would have a normal force, let's call it n2, but they're transverse to the motion. All this accelerates to the right with a value of 7.5 meters per second squared. So there's our free body diagram. Setting up Newton's second law for that, we would say the summation of the forces in the x direction is equal to m2a, and that is equal to P. That's it. So P is equal to 2 kilograms times 7.5 meters per second squared, 15 newtons. So that's the force of the block 1 acting on block 2.